also wanted to mention in the introduction, I'm currently on a short-term detail with the Office of the Chief Scientist for USDA. That's Kathy Wotecki, the Undersecretary for Research, Education, Economics mission area. And it's given me a kind of unique opportunity to see what happens at NIFA, the Extramural Granting Agency, ARS, National Ag Statistics Service, and Economic Research Service. So those are the 4 agencies within REE. I'm only there till the beginning of May, but I am making a lot of good contacts, so I hope I'll be able to maintain that moving forward and kind of be able to tie in and understand things at a little different level that I'm used to seeing. So what I want to talk about today is the status of U.S. aquaculture research. I'm really going to focus on federal research, which is what I know best. But really, over the last several years, federal funding for aquaculture research has been really challenged. It's been declining. But there's still really a strong need for aquaculture in the United States and for aquaculture research. And I want to talk about that, some of the drivers of that need, and then talk about some of the, I guess, the silver lining or the benefits of the reductions in funding. It's really forced some successes from the ongoing research. And I want to describe a couple of those successes. So as the first speaker, I figure I get to show this graphic of how aquaculture is growing in the world. I also, when I first looked at the people coming to the meeting, it didn't have everybody here on it, and I wasn't sure how familiar everybody was going to be with aquaculture. So I just wanted to make the point that aquaculture now provides about half of the seafood consumed in the world, and that fraction is going to increase. Our oceans are mainly fully exploited, so any additional seafood production is going to have to come from aquaculture. So do we need aquaculture research in the United States? I think it's a question that we need to start with, and right now the United States represents probably about the 3rd largest seafood market in the world behind Japan and China. So we're eating all the seafood we need. Do we need aquaculture and aquaculture research in the United States? Well, what does aquaculture bring us? First of all, it's an extremely efficient animal protein production system, probably the most efficient. And this comes from, Conservation International in 2011 produced a publication with World Fish and identified aquaculture as the most efficient protein production system, animal protein production system. And it's not only is it excellent protein, but generally it comes along with those helpful omega-3 fatty acids, a number of essential vitamins and minerals, highly digestible. Not only that, but aquaculture in the United States has the opportunity to create working waterfronts, jobs in coastal communities, and in the agricultural heartland. We have the abilities to produce feeds and supply feeds to our fish like very few other countries. But I think it's hard to see in black up at the top, but the seafood trade deficit in the United States in 1977 was about $2 billion. In 2011, it was $10.4 billion, and in 2012, it was closer to $11 billion. And over 86% of our seafood is imported. So anyway, we're getting the seafood we need, right? So do we need to increase production in the United States? I think a really important point, and I saw George Chamberlain talk about this in 2011. If you look at where the middle class in the world is and where it's going to be, in 2009, you see that, it's a little bit hard to read this, but about 18% of the middle class is in North America, 36% in Europe. So anyway, about 54% of the middle class is in North America and Europe in 2009. By 2020, it's about 30%. By 2030, it's 21%. And by 2030, the Asia-Pacific region has 66% of the middle class. So in the opening sessions, our speakers talked about the increase in meat consumption as affluence grows. So as these communities become more affluent, the demand for seafood is going to grow, and our market, our ability to drive those markets is going to decrease. So if we're not producing seafood in the United States, our ability to get seafood is going to really be challenged. It's going to be much more expensive and hard to get. In last year, China was a net importer for shrimp. They produce a lot of shrimp in China, and they're still importing more. So it's really going to be difficult for the United States to rely on getting as much seafood as we do now. Furthermore, we've seen some dramatic shifts already. When Chile went through the salmon crisis in 2009, 2010, Brazil became a huge buyer, and Brazil is already consuming a lot of the Chilean-produced salmon. So in order to be able to buy and find the seafood we need, I think it's imperative that we increase production in the United States. So some of the key elements of the research system are, of course, the resources, human and financial, and these resources are represented through academia universities, the government, a lot of input from industry and farmers, and non-governmental organizations. There's the important development of ideas and everything from maybe basic or fundamental ideas to applied. At ARS, we generally talk in terms of solving problems. If the problems require basic fundamental research into genomics, we do that. If it's applied, finding the right ingredient for feed or a better incubator, we will work on that as well. And a key point is working with the industry, working to do the tech transfer and extension, and really integrating the work across all of these domains is a key to success. And with the decrease in federal funding for aquaculture, we've seen a real push towards multi-institutional research, multidisciplinary research, working more closely with industry and public-private partnerships. And I think that this has been a real benefit of the lack of resources. It's forced us to integrate and collaborate more. I wanted to just show briefly some of the federal resources for aquaculture. The little fish that I've got here are ARS aquaculture laboratories. So there's actually 11 sites across the United States. 5 years ago, I would have said 16. We have 55 scientists. 6 years ago, it was 65. 5 years ago, it was 65. So things have shrunk some. In red, these red stars are the centers for the regional aquaculture centers operated by NIFA. And I know many people in this room are associated with those. So we've got the northeastern rack, southern rack, north central rack, the western region, and the Pacific Islands rack out in Hawaii. And then I've also indicated with black flags the NOAA regional aquaculture centers. So there's a northeast, southeast, northwest, and southwest, and again, one in Hawaii. And there's a number of aquaculture labs that NOAA, or a number of labs that NOAA operates that have aquaculture activities. Sea Grant is across the United States. I haven't indicated all of the resources, but I just wanted to give you a feel. And also mention, you can see a concentration in the south, which indicates the importance of traditionally of catfish production in the United States, the #1 aquaculture species. Increasingly, the role of private and non-governmental organizations is huge. I don't know, probably many of you are familiar with the Layla project that was driven by Neil Sims and Kona Blue in Hawaii. This is a picture of their circular cage that was towed by a boat for about 6 months. There was funding from National Science Foundation, as well as the Illinois Soybean Association, and a number of other participants. But in a 4-month period, they took Spirulina riviolani, the yellowtail that they produce, from about 180 grams to 4 pounds in 4 months. So it was really a tremendous demonstration. It was quite small scale, but it was really an excellent demonstration. Hub SeaWorld is an important contributor to research. They do a lot of work on the white sea bass, hybrid striped bass, developing new cage methods, new hatchery methods. Moat Marine Lab is doing some really cutting-edge work with sturgeon and caviar development. This is got a small picture of a caviar package from Moat Marine Lab. And then I really can't stress enough the role that the United Soybean Board has played in aquaculture promotion and development in the United States. It's really amazing to me that the soybean world has paid so much attention to aquaculture, which is really a very small entity in the United States, but I think they see the potential and the growth of aquaculture as a real value to soybean producers. And what I've heard some farmers say is, we'd much rather sell $10 worth of fish than $2 worth of soybeans. So let's improve aquaculture production in the United States. So the United Soybean Board, the Qualified State Soybean Associations, QSSBs, and the newly formed Soy Aquaculture Alliance. It's nice to see Steve here, the director of that group. So as I mentioned, resources are constrained, and I think the initial reaction was to try to do more with less. Resources are tighter, so everybody takes a little bit of a haircut, and you try to spread the pain out and do more with less. But it's really gotten to the point where we've had to decide to do less, but do the things that we do better. Have better coordination, better integration, focusing on key problems, concentrating resources, and where we see some successes, really push those successes through. Think more economically. What is the value of the investment in research? Everything's an economic question. We have unlimited desires, limited resources. So it's got to be an economic thought process. What's the potential outcome, and how is it going to change the industry? And as I mentioned, we're really working to integrate across domains, multi-institution, multi-stakeholder, and even within the government. I think it's safe to say that the relationships among ARS, USDA-ARS, NIFA, and NOAA, and the rest of the federal partners as well, has never been stronger. We talk and try to coordinate, understand what everybody is doing to a degree that we really haven't done before. Part of that is the Joint Subcommittee on Aquaculture Strategic Plan for Aquaculture. Public draft was released last year, and final version should be released by this year in 2013. So some of the key production challenges under research, and these are all familiar to you: reducing the cost of production. We're looking at faster growth, lower feed costs, better control of reproduction, reduce loss to disease. This is a big area, and there's a number of emerging diseases. Aquaculture probably contributes to the emerging disease area more than most of the other livestock production systems. Work on improving production systems, and I'll talk a little bit about a new production system, and generate product variety. We have a new ARS project in New Orleans looking to develop new catfish products. So when you go to the supermarket and you see 40 different types of tilapia, panko encrusted, lime flavored, and catfish is either fillets or whole fish. So we're really looking at trying to develop new products. I wanted to list a few areas that I think really are bright spots for U.S. aquaculture, and research has played a role and should play a continuing role in the development. There's really been a nice growth in the molluscan shellfish area, Atlantic salmon production on the east and west coasts. I want to talk about catfish. This has certainly not been a recent success. The industry has really suffered lately, but I think there's some real bright spots there that I want to talk about. Some work in recirculating systems I think is promising. We're doing a lot of work in feeds development, new ingredients, and I'll talk more about that as well. And then I think in the area of broodstock development, genetic improvement, we have tremendous potential in the United States. We have a great history of work in terrestrial species, that we can draw on. We have great experts in the United States to build this area. And I'm a little bit partial. My background is in genetics and breeding, but I look at the people we have in that field today, and I think we have a lot of potential. So I'm going to move into a couple of short descriptions of research areas that I think illuminate a couple of points about working with multiple stakeholders, trying to push the advantage where we've had some success, and really drive that to economic development. So first, I'm going to talk about alternative ingredient development. And a lot of the work has been driven by this fact. The blue bar here shows the price of fish meal from December of 02 to 09, and then the current price, this is about 6 months ago in September of 2012. But you can see that the price of fish meal has really skyrocketed. You know, the use of fish meal is often pointed at by environmental groups as a real negative of aquaculture, and I think you know, we want to be responsive to that, but it's really I think a red herring, no pun intended. You know, the real problem, you know, the swine and poultry industries went through the same thing in the 70s and 80s. They were very reliant on fish meal, and it just became too expensive, and they found alternative sources of protein. We're really doing the same exact thing. The amount of fish meal that's harvested will not change. It's going to pet food and the omega-3 capsules that you can buy. It's a very sustainable fishery, about 30 million tons a year, and that's likely to continue. But the price is really driving alternative ingredient development. And on the bottom here, I have the price of soybeans shown. It's also gone up by a factor about threefold over the last 10 years as well. And there's even talk about, you know, alternatives to soybean. But the amount of soybean produced, about 68–70% of the feed protein in the world is soybeans. So we're going to that's going to be a big ingredient. So the research I'm going to talk about has really been led by a team out of Bozeman, Montana, and Hagerman, Idaho. Rick Barrows, Wendy Seeley, Gibson Gaylord. I'm just mentioning this for the people that know these folks. A lot of work with Hub SeaWorld, Schillinger Genetics. Bill Walters has done trials with salmon in Maine. I just want to recognize those people if I don't later. So developing a new ingredient, there's really some very important steps that you might not think of right offhand. So, you know, a new ingredient, of course, it has to deliver the important nutrients, you know, the proteins and the right profile of amino acids and fatty acids. With soybeans, we also have to look at the anti-nutrients and what we can do to remove some of those saponins and protein protease inhibitors and things like that that can affect the digestibility of the soybean. But no matter how good an ingredient it is, we have to check and make sure that the fish will eat it. You know, do a palatability test. And really, these are the first two steps that we do before we do any further analysis. And then we need to look at the digestibility. You know, there could be a lot of amino acids, a lot of good protein in an ingredient, but if the fish can't digest it and get that, make that protein available, it's really worthless. And then things that I never used to think about until I started talking to Rick Barrows on a regular basis is, you know, how functional is this ingredient? It can be a great ingredient, but if the pellet falls apart, when it hits water, you can't use it. So it has to have the ability to make a good pellet, have good expansion so it'll absorb oil, be durable in water. You know, all of these things have to be tested. And then finally, we look at growth and how well does the fish do on this on these diets with this ingredient. So it's really quite a detailed, involved process. I want to talk about some work that we did with Spirulina. This is a blue-green algae being produced by Carbon Capture Corporation in California. It's really a nice ingredient. Daniela is another algal crop that's high in oil, and it's being investigated. I'm really just going to talk about Spirulina, which is used as a protein source. It's high, once it's dried, it's high in protein, 60 to 70% crude protein, so a very high protein ingredient. It's easy to separate from the water. It's also very tolerant to high alkalinity. And this is important because you can grow ponds or large raceways of this without contamination. Because you can have very high alkalinity. Other species can't grow in the culture, so you can get very uniform, pure cultures of spirulina, which is important. There's lots of capacity to increase production using irrigation water, and in California, plenty of sun, 365 days of sun a year. So this has been a really interesting ingredient, working with Aquaculture Corporation to develop that. And I just want to show a couple of interesting points. So this slide shows data from, I have a little pointer here, I don't know if you can see it, but we've got a fish meal-based diet with 0, 10, 20, and 30% spirulina for protein, and then a fish meal-free diet with 0, 10, 20, and 30% spirulina added. And everything is being compared to this control Skretting marine gold diet. So it's a very high quality control diet. And what we see is that the gain on the spirulina diet in the fish meal free diet, when we add 30% spirulina protein, we get a very good gain, very good growth. So part of it is from higher feed intake, but the food conversion rate is still excellent. There's no significant difference. So it seems that there's some palatability enhancer. The fish really go after this diet. The other thing I wanted to point out is that when it comes to survival, the fish meal free diet with the spirulina does not do as well as our fish meal control or the marine gold Skretting diet. However, when we get up to 30% of spirulina protein, where there's no significant difference. So it looks like there is some key nutrient that's missing in the fish meal free diet, and as we add spirulina, we're recovering that. So we haven't identified what that nutrient is yet, but it's very interesting for doing future research in this area. And I meant to say that the ingredient that we're using is from Aquaculture Corporation, and a lot of this work is taking place at Hub's SeaWorld with the white sea bass. Another area that we've been doing a lot of work on is using the improved genetic lines of soybeans from Schillinger, especially from Schillinger Genetics. So one of the points I wanted to make here is the interdisciplinary, multidisciplinary nature of this research. You know, we're working closely with plant geneticists that are modifying the plants to make a better ingredient for fish. So really multidisciplinary. This is a number of the anti-nutritional factors that we're working on. The lipoxygenase, trying to increase protein levels, have high protein, reduce the oligosaccharides, reduce trypsin inhibitors, all of these things. And these are all being produced non-genetically modified organisms, so it's classical breeding. We're finding that one of the important developments has been an ARS fish meal free diet, which gives good growth and can be used as a base for substituting new ingredients in. So this has been a very important baseline development for testing all kinds of new ingredients. That's the end of my feed story. I just wanted to point out that there's some very high-value alternatives being developed and are currently available for testing and production on a commercial basis. These are characteristics of all the characteristics of the alternative ingredients have to be tested to determine the real nutritional and economic value. And a real key point here is that Rick Barrows and this team are bringing together ingredient producers with feed manufacturers and trying to shorten that chain and get those ingredients into commercial use. So I think this is one of those benefits of reduced funding has led to it's really forced the need to have these collaborations. So the next example I want to talk about and kind of develop here is work, really a great multidisciplinary a multi-institutional effort in Mississippi working with catfish. So at Mississippi State University, we have the Ag Experiment Station, the Veterinary Medical College, the Extension Service, and the USDA-ARS has a big lab, and NIFA's Regional Aquaculture Center is based out of the same National Warmwater Aquaculture Center. The work I'm going to talk about has really been developed by Craig Tucker, Liz Torrens, Brian Bosworth, and Nagaraj Chattokondy. So first, the really shocking, terrible news of what's happened with farm-raised catfish production. From a peak in about 2003, production has fallen, and if we extend this graph to 2012, it would drop down to about 350 million pounds produced last year. So we've lost over 50% of the catfish acreage in Mississippi, Arkansas, Alabama, and Louisiana. There's been a number of problems. Competition from Asian products has been huge. I'm not going to go into that. That could be a big talk all on its own. But the feed costs and fuel costs that all animal industries have faced have really been huge for catfish because there's so many products that can substitute. We don't have that same problem with beef or chicken or pork, but when it comes to a white flesh fillet, there are many substitutes. There's been increasing mortality problems. So today, to grow a channel catfish harvest out to 60% survival is not unusual, and it's really a huge problem. The production cycles have gotten longer. From an 18-month production cycle, it's not unusual to have fish in the water for 3, even 4 years. This contributes to higher mortality, poor feed conversion rates. So this has kind of been a snowball. But there's been some real bright spots lately. And one is the production of a hybrid catfish. This is a hybrid between a male blue catfish and a female channel catfish. And it's been known for 40 years that the hybrid is really an excellent fish, but producing enough has been a problem. The females have to be, the eggs have to be stripped from the female. It's very labor intensive, and we weren't producing as much as 10 million fry a year, and the industry needs about 1 billion fry, so it really wasn't even a recognizable fraction of the industry. But over the last really 10 years, but especially in the last 5 years, improvements in synchronizing the female readiness using hormonal treatments, better incubation and hatching practices have increased the production of hybrid fry, so that last year in 2012, there were over 150 million hybrid fry produced. As the industry has shrunk, this 150 million fry represents about 20% of the industry, and survival is better. So by the time you get to harvest, this actually represents more like 30% of the industry and growing. So the advantages of this hybrid, it has increased growth rate, better feed conversion, better survival. There seems to be resistance to some of the major diseases like enterosepticemia of catfish, ESC. They also have a better tolerance for low dissolved oxygen. Of course, the disadvantage is production of these hybrids is still quite labor intensive, but there's been a lot of training in the industry and a lot of improvements in production. Another point I want to make is it's kind of shocking to me that the strategy for raising catfish for 35 years was keep the fish alive. It wasn't grow the fish, it was keep the fish alive. So the idea was to keep the oxygen levels in the ponds at night at a level that the fish could survive. It would drop down below 1 part per million, but the fish would live. But the next day they wouldn't eat. So this contributed to these long production cycles. They wouldn't eat and grow. So over the last 10 years, Les Torrens has done a series of studies that show that if you keep the oxygen levels really above about 2.5 parts per million all night long, that the fish will eat every day and continue to grow. So it's really changed the growth production cycle. Another innovation has been aerator placement. So these sounds like things that have really simple fixes, but traditional aerator placement looked like this. There was laminar flow trying to aerate a 10-acre pond And the oxygen levels here near the aerators were high, and they drop out very rapidly. The new placement strategy is to develop a small area of the pond with higher oxygen levels, let the fish move into the high oxygen levels in the morning when the oxygen levels in the pond are low. And this has resulted in 15 to 20% less cost of aeration. This is already being done in ponds in Mississippi. It was worked on with commercial producers from the very beginning. So we know this works. And finally, I want to just mention briefly the split pond technology. I don't know how many of you have seen this yet, but it's a relatively new technology developed at the National Warm Water Aquaculture Center. The idea is, again, these numbers are the dissolved oxygen levels. So up by the aerators, quite high, 2.5, and then as you move away from the aerators, oxygen levels drop off rapidly. So this new production system, there's a fish holding side and a waste treatment side of the pond. So the fish holding side is dug down deeper, and that earth is used to build a levee between the two sides of the pond. This is about 20% of the area and about 80% of the area. And then the levee is breached by a paddle wheel that pumps the waste out of the fish side and another sluice way that allows high oxygen water to come back in. So during the day when photosynthesis is going, lots of oxygen produced out in this side of the pond, the paddle wheel moves, it drives high oxygen water into the fish side. When night comes, photosynthesis stops, we have aerators that high capacity aeration on the fish side. So this is it's expensive to build these ponds, but production on commercial ponds has been fantastic. So this is a picture of an actual pond. This is a relatively small 2.5-acre pond in Stoneville, but it gives you the idea. So this is the fish side and the water treatment side. Here's the paddle wheel and the sluice way for return flow. A couple of tests have been done. Actually, over 7 years of experimental tests have been run, but this is on a larger commercial scale split pond design, going with a typical size fingerling, about 40 to 50 grams, to a final weight of about 1.7, 1.8 pounds. Over one production cycle, average over 90% survival. So this is using the hybrid catfish, and production averages over 15,000 pounds per acre. This is over the entire pond, the fish side and the water treatment side together, over 15,000 pounds per acre. A traditional pond in the delta of Mississippi would produce about 5,000 pounds per acre if it was a good performing pond. So really fantastic production rates, excellent food conversion rates, under 2, which is really excellent for catfish production. Typical would be closer to 3. So just to summarize, the production of the hybrid fish has been a real innovation. The oxygen levels, seem simple, but it's really changed production dramatically, shortened the production cycles. Working in the split pond area, you get not only does the hybrid catfish feed more aggressively, but feeding into a smaller area improves the delivery of feed. The health is better, the hybrids are resistant, and if you have to treat the split pond, the concentration of the fish makes that easier. Harvest is easier because it's more efficient in a small area. Predation by birds is a big problem. In the split pond, you have a smaller area to protect. And an important point is that all of this work has been done in conjunction with producers every step of the way. And producers have come in, built these ponds on their own farms, and found ways to make the sluice waste cheaper and really economized. But 2 years ago, there was over 1,000 acres of commercial production. In 2012, there were 2,000 acres of split pond production in the industry. So it really seems to be catching on. So in summary, I just want to say that I do believe that there's a critical role for research in aquaculture development in the United States. I think that we need to focus on a few key industries. This maybe is the controversial bit, something that we can talk about. How do you pick? But I also think it's important to be working on technologies that are adaptable across many species, like the feed ingredient development. There's a USDA stakeholder meeting coming up this summer. Date has not yet been set, but this is a joint meeting with ARS and NIFA, a listening session to stakeholders. The last one we did was in 2008. This is not going to be, we don't have the funds to hold a big workshop where we invite a lot of people. It'll be a web-based meeting. And I'll get information to everybody soon, in the next month or so. And I mentioned earlier the Joint Subcommittee for Aquaculture Strategic Research Plan due out in 2013.